Hi everyone. I will be presenting the work that we have been doing at the Laboratory Animal Science Group at I3S with a poster entitled From Lots of Litter to Lots of Data, a Behavioral and Acoustic Data Acquisition System to Surveil Mouse Trios and Their Pups. Monitoring mouse behavior is vital in biomedical research, supporting studies on neurological and psychological disorders and drug effects. Behavior monitoring is also important for assessing laboratory mouse welfare and improving their care. However, monitoring mice behavior can be difficult due to their small size, nocturnal activity, and highly gregarious nature, especially during reproduction when nests often block visibility. Our objective was to develop a continuous, cost-effective system to monitor behavior and ultrasonic vocalizations in breeding mouse trios. The system was built to be adaptable, accessible, and fully aligned with the 3Rs framework. As a model, we used Black 6 mice, one of the most widely used mouse strains in biomedical research. We adapted published 3D printing files to build camera and infrared light mounts and designed custom support for ultrasonic microphones, ensuring stable but flexible positioning. For each cage, the recording system included 3 RaspberryPi ZeroW cameras, which gave us 3-sided video coverage, and 1 ultrasonic microphone for continuous audio recordings. We used breeding cages from our research facility, and briefly the cages were moved to the recording room and the cage shelters were opened to improve visibility, while still keeping partial cover as enrichment. The animals' tails were also marked for individual identification. We usually recorded continuously with cameras and microphones for approximately 1 week and performed daily checks to count pups after parturition. Once the recordings were completed, the cages were returned to the breeding colony. This setup generates large video and audio datasets from continuous cage recordings. It also provides a 3-sided view, which reduces blind spots and improves visibility. This makes it easier to follow a focal animal, for instance, which is especially useful when recording mouse trios during breeding, when there is a lot of nesting material, pups, and also adults moving around. As we can see, the right panel shows different frames of the same cage at the same time. In the right side view, we can clearly see the nest and pups, which are not visible in the other views. The image below is a spectrogram of audio recorded with this setup, where the rectangle highlights an ultrasonic vocalization during a copulation attempt. This setup enables data-driven insights into reproductive behavior, communication, and welfare. It is an affordable system, highly adaptable to different research teams, strains, or even species, which is why we are eager to share it with other researchers who might find it useful for their own work. Last but not least, this setup was designed following the 3Rs framework. Using cages from the existing colony helps avoid breeding extra animals, contributing to reduction, and the system supports refinement by allowing behavioral and acoustic monitoring with minimal disturbance. I conclude the presentation of our poster here. I will leave you with some information about our group and also about the main focus of our project. Just scan the code to learn more. Thank you so much for your time and also for your patience.